An emergency is an unexpected occurrence and requires immediate action. In a place like workshop, such a situation can arise when a person gets a shock due to electrical current, or a person gets injured by the rotating part of a machine. In such situations, switching off the supply will be the first and best solution to avoid further damage to the victim. For this, every person involved in the workshop should be able to identify which switch controls the area where the victim of shock remains. Normally, the total wiring in a workshop is controlled by a main switch, and the different areas within the workshop may have 2 or more sub-main switches. At the end of this exercise, you shall be able to identify the location of switches and their control area. Draw the layout of the ITI wireman section. Operate the identified switches in case of emergency. Identify the location of switches and operate them during emergency. Identify the main switch and mark its position in the layout. Identify each of the sub-main switches, their area of control in the section, and mark them on the layout. Identify 3 or 4 spots in various locations of the wireman section layout and identify the respective The polarity of DC supply source should be identified as positive or negative.
This term can also be used to indicate how an electric device is to be connected to the supply. For example, when putting new cells in a transistor radio, we must put the cells correctly such that the positive terminal of one cell connects to the positive terminal of the radio, and the negative terminal of the other cell connects to the negative terminal of the radio. The most common sources of DC supply are the cells or batteries and DC generators. At the end of this exercise, you shall be able to identify the terminals of a MC instrument with respect to polarity. Determine the polarity of a DC supply source using an MC voltmeter. Determine the polarity of a DC supply above 80 volts with neon tester. Determine the polarity of the multimeter prods in resistance mode. Assumption. The terminals of the MC voltmeters are identified either from the color of the terminals or polarity marking. Battery terminals are unmarked. Connect the test leads to the 0 to 150 volts MC voltmeter. Connect the red test prod spade lug side to the positive terminal of MC voltmeter and the black test prod spade lug side to the negative terminal. Relation between the electromotive force, current and resistance of a circuit is given by Ohm's law. Click on each tab to know more about it. Electromotive force. An electromotive force is an electrical force and essential to drive the electrons in a circuit. This force is obtained from the source of supply, that is, torch cells, dynamo, and denoted by the symbol E. Current. The flow of free electrons in a conductor by applying some pressure or force in unit direction is called current. Its unit is ampere. It is denoted by the letter I and it is measured by a meter. Resistance. It is a property of opposition offered by the substance to the electric current. It is denoted by R. Its unit is ohm. Potential difference. The difference of voltage across 2 points in a circuit is called a potential difference and is measured in volts. At the end of this exercise, you shall be able to identify the type and range of voltmeters and ammeters. Identify the resistance value and current range of rheostats. Connect a rheostat as potential divider and fixed resistance. Connect a rheostat as potential divider and fixed resistance. Connect and read voltmeters and ammeters. Verify Ohm's law experimentally. Identify the voltmeter and ammeter. Verify the range of the voltmeter and ammeter. Identify the contact parts of rheostats to be connected as potential divider and the standard resistance. Connect the power supply, switch, fuse, meters and rheostat. Keep the moving arm of the potential divider to have low voltage at the output of the circuit. Short circuit. A short circuit is a path of zero or very low resistance compared to the normal circuit resistance. Defects due to short circuit. Excess current due to short circuit can damage the circuit components, power sources, or the installation of connecting wires. Protection against short circuit. Dangers of short circuit can be prevented by means of fuses and circuit breakers in series with the circuit. Series circuit. Examine the effects of short and open circuited resistors in a series circuit. Construct the circuit as shown by connecting the circuit elements and voltmeter. From the circuit, calculate the nominal values for the voltages VA, VB, VC and record them in table. Considering resistor R1 as shorted, calculate and record the resulting voltages at A, B and C if this were to occur. Now consider removing R1 open circuit. Calculate and record the resulting voltages at A, B and C if this were to occur. Enter the calculated values in table under the heading Open Circuit Conditions and Calculated Value. A magnet is a substance having the properties of attracting iron
and its alloys like nickel, cobalt, etc. and when suspended freely, points directly towards the north and south directions of the earth. Kinds of magnets. Magnets are classified into two groups. A. Natural magnets. B. Artificial magnets. Natural magnets. Lodestone, an iron compound, is a natural magnet which was discovered centuries ago. Artificial magnets. There are two types of artificial magnets. Temporary magnet. When a piece of magnetic material, say soft iron, is placed on a strong magnetic field of a solenoid, it becomes magnetized by induction. The soft iron itself becomes a temporary magnet as long as the current continues to flow in solenoid. Permanent magnets. Steel is a suitable material for the construction of permanent magnets, since its power of retaining magnetism after the magnetizing field has been removed is high. This property of retention is termed retentivity. At the end of this exercise, you shall be able to identify the magnetic and non-magnetic materials. Identify the polarity of magnetic compass. Find the polarity of permanent magnet. Trace the magnetic lines with the aid of a compass needle and iron filings. Sprinkle the iron pins or fillings on the laboratory table and bring the given bar magnet nearer to the iron pins or fillings. Observe the actions and record in the table under column 1. Repeat for the other items indicated in table and record your observations.